These are the notes for N27, the quartic functions and translations. Let's start by sketching the parent function. Okay, the parent function for x to the fourth power is here. You need to memorize what this graph looks like. The range, or I'm sorry, the domain is all real numbers, and then your range is going to be greater than or equal to 0. First example, reflect across the x-axis and then translate it 3 units to the right. Remember, all of these notes are going to deal with x to the fourth power. So when it says reflect f of x, we're going to be talking about x to the fourth power. Okay, I'm going to start by writing the equation that shows how to reflect it and how to translate it. 3 units to the right. All right, the negative x minus 3 to the fourth power. All right, so to graph that, I'm going to start off with the parent function, and then I'm going to show you what it looks like reflected. If I flip it over and then move it over to the right 3, this is what it's going to look like. Okay, notice the domain there is going to be all real numbers, and then the range is never going to go above 0, so y less than or equal to 0. All right, number 2, translate the function 3 units to the left and 1 unit down. So that would look like this, x plus 3 to the fourth power minus 1. All right, let's graph the parent function first. I need to move it 3 units to the left and 1 unit down, so this is how it's going to look. So again, the domain is going to be all real numbers, but the range now is bound by -1, so it's going to be greater than or equal to -1. All right, example 3, we're going to write the equation from a graph this time, and we know that it's going to go through the point 1, -96. So let's just start by looking at the roots. The roots are -2, 1, 3, and 5. If we write those as factors, look like this. Okay, and then to write it in factored form, we're actually going to have to solve for a. Okay, we're going to need to figure out what a is, and how we're going to do that is we're going to use the point that's on the graph. Okay, so we'll start with the factors, then let's use the point that's on the graph, plug in the point, 1 for all the x's, and -96 for for the y value, the f of x. Okay, multiply that together, 1 plus 2 times 1 plus 1 times 1 minus 3 times 1 plus 5. Okay, that's going to give you -72a. Okay, and then when we divide by -72, we get a is equal to 4/3. So just simply put that right back in to the function, and then that is your equation in factored form. Okay, the next example, write the equation that goes through the point -1, -162. Okay, again, we're going to start with the roots, but when we look at this graph, you can notice that part of it is flattened. Okay, and something I want you to remember is that triple roots will flatten your graph. Okay, so right there at x equal -4, okay, that's going to be considered a triple root. And then we've got x equals +1. So writing those as factors would look like this. Okay, and again, to write this in factored form, we're going to need to solve for a. All right, so using our factors, we're going to plug in the point -1 and 162 in for y and for x. Okay, -1 plus 4 to the third power, that's going to be 3 cubed, which is 27, and 27 times -2 is -54. So -54, we divide both sides by -54, and we get that a is equal to 3. So plug that back in for a, and then there's your factored form of the function. on the next example, I'm a quartic with a double root at -2 and roots at 1 and 3. On this one, we don't have a picture of a graph to start with. So we're just going to look at what they tell us, and then we're going to put all that together. All right? If you're a double root, okay, this one is going to cause the graph to kind of bounce back at that point. All right? So if it was tending to go down, it's going to go bounce back up, and vice versa. All right? Let's go ahead and start by graphing our roots. Okay, and then before we can finish, we're going to need to find the y-intercept. So plug in your x equals 0 across the board, and that ends up to be 2. All right, and then now we're going to pick some test points to determine the direction of the graph. So if I choose the point x equals +2, then my answer is -8, which indicates the graph is below 0. And then if I choose +4 for x, then I get a +108. So that indicates the graph is above the x-axis. Okay, and then go ahead and connect those points. Since we had a double root at -2, okay, that's where the graph would bounce back up. All right, the function is going to be written as f of x equals x plus 2 squared times x minus 1 times x minus 3. Okay, on this last example, a quartic with a negative lead coefficient and a triple root at -2 and a root at 3. Find my function and sketch me. All right, so pay attention to the clues here. It says it's a triple root at -2. So we know at -2 there's going to be a flattened part of the graph. Okay, so let's go ahead and graph the roots. All right, and then we need to find the y-intercept. Okay, and that's going to be at 24. And then your test points. I chose -3 and 4. Okay, you could have chosen -4, any number to the left of -2, any number to the right of 3. All right, so when I plug in -3 for x, I get a -6, so the graph's going to have to go below x-axis after it goes through the root of -2. Okay, and then when I chose 4, I got a negative number as well. Okay, so whenever we put all that together, the function would be written -x plus 2 cubed times x minus 3. Okay, and then you connect your points. Notice there at -2, there's a flattening of the graph. Okay, that's going to indicate your triple root.